Welcome back everyone. Here's a tutorial looking at an engine failure in the cruise, and we'll have a look at the way we would handle it on the airplane and then run the QRH. So just to have a look around at the moment, we can see that we are cruising just short of 37,000 feet. In VNAV path FMC speed, so the auto throttle's controlling the speed in the flight management computer. So if we have a look at cruise, decimal 775 and a cruise out of 37,000 feet. 775 rounded up to 78. It's in LNAV, so it's following the magenta path and the active route direct at the moment to Al-Had, and VNAV path will be following the VNAV path or the vertical profile, which at the moment is just leveling the cruise at 37,000 feet. Just having a look at the top, so center tank fuel pumps are off, main pumps are on. We are on the outbound sector, so for us that would be the right ignition. Pressurization panel set at 37,000 feet and a destination landing altitude. Pressurization panel, air conditioning panel, all normal. So just so you can follow this to be able to set this up for yourselves, we need to go into the CDU, failures, engine. I'm just going to do an engine number 2 flame out. So just as a aside, if you fail the number 2 engine and the autopilot B is engaged, immediately after the engine failure with the electrical bus transfer, it will drop the autopilot out. You can reselect it, but just for one less click for me, what I'll do is I'll fail the number 2 engine, which, because we use an autopilot A, that'll keep the autopilot in just one less thing for me to do whilst I'm trying to demonstrate. So there are no memory items for an engine failure. For some strange reason, the PMDG decides to restart the engine whilst I'm trying to talk my way through things on here. So I will do 2 of the actions. I'll close the thrust lever and the fuel lever to cut off quite quickly, and then I'll talk about it more practically as at the right time, just to stop the engine restarting on its own. Obviously wouldn't normally do that. So something that you may want to discuss in the cruise. First of all, when I cruise and engine out, select either side, so it'll tell you that if you lose an engine, the target speed will be 242 knots, and we can attain with maximum thrust on the other engine flight level 233. So in order not to max out the other engine and to just give time to demonstrate, we'll assume that we'll use 170 for the altitude that we'll descend to. We've checked that with the terrain in the area to make sure that we're not descending into any high ground. 170 will keep us safe in this instance. So we can put 242 up here, just as on the left hand side. So here we've got about 6 knots to lose before we want to start the descent for the target speed, and we could put on this side, we haven't got to do this, this is just to give you an idea, some people use this, 170. So the 2 sides of your PFD, you've got a left hand target of 242 and a right side target altitude of 170. Write them down on a piece of paper, put them up there, put them somewhere else, up to you. So with that in mind, we'll go back towards the engine failure. Programmed to engine number 2 just flames out. active, yes. So once I execute this, the engine will fail, so I'll try and keep that in the screen as well. Here we go, engine's failed, N1, N2, and the auto throttle's just dropped out. So it's number 2 engine, so I'm just going to close number 2 thrust lever and fuel to cut off. That'll just stop that restarting just while I demonstrate. So as you can see, so we've got 6-pack annunciation of a leck. So if we have a look up here, you can see that the generator has dropped offline because the engine's failed. The generator's off bus, and the source that I used to select, which was its original generator, has gone off. It's actually being powered from the left hand side, but that's not how we'll leave it, and we'll see that in a minute. So the drive light's on at the minute. The engine's still running fast enough to keep the engine driven hydraulic pumps on, so we can expect in a short while that we'll get hydraulics on here as well. So we'll look at that as and when we come to it. So at the moment you can see the speed's already started reducing, so we want to set our target speed of 242. So we want a lower altitude initially, just put any altitude in at the minute, level change, Mach to indicated airspeed, 242, and our altitude we wanted to set was 170. So whilst that's set at that, and the aeroplane will descend with this. Set 170 in here. For the N1 limit, we want to set the reference thrust to max continuous. So that'll come here, and then we can use manually increase the thrust on the operating engine. To give us max continuous thrust and limit the initial rate of descent. Looking across to this side onto the live engine, which would be the number 1 engine, you would start to see that the ailerons start to turn in towards the live engine, and then you'd need small amounts of rudder trim to just enough to centralize the ailerons. Very, very small amounts. There's a big rudder on this aeroplane, so you need a very small amount of rudder, and certainly with the push on the pedals before you trim it very, very gently at this altitude. So, blanking the master caution for the time being. So we can see speed's under control now. It's descending at our target speed. Rate of descent's only 550 feet per minute, and we're at our target thrust, which we can keep adjusting, and that'll keep us going for the time being whilst we get the QRH out. Obviously, for pilot monitoring at this point, he's monitoring everything. He or she's monitoring everything that you're doing and telling ATC that you are a mayday and you've lost an engine and your intentions, just to give them a heads up so they can clear everyone else out of your way. We won't focus as much on that. We'll just make sure we go through the steps of the QRH. So first thing on the QRH, engine failure or shutdown. Well, it failed. So airframe vibrations with abnormal engine indications do not exist. So that's the scenario that we've got ourselves here. So auto throttle if engaged, disengage. So the auto throttle is already disengaged. Thrust lever of the affected engine, confirm that it's closed. So confirmation with the 2 pilots to confirm that that's closed. And then when it's at idle, confirm to cut off. Now obviously I did that earlier just because I didn't want the engine to restart itself, but that's at the point now that you would do that as you follow it through the checklist. So pack switch for the affected side off. So we're back up to the top. So number 2 engines fail, so the pack switch on that side to off, with the isolation valve in auto. That'll allow the operating pack to operate in high flow with the flaps up. Next, is the APU available to start? Well, we're assuming yes it is, so let's start the APU. Just whilst we're waiting for the APU to start, we'll just look a little bit further down the QRH. It says to balance fuel as needed. Obviously you're only using fuel from the one side now. So 1.7, 1.82, so not a huge discrepancy yet, so not really much of an issue for us anyway. And the airplane is certified to land anyway with empty tank on the one side. Other considerations, that would have been in TARA. So other considerations now that we put the transponder to TA only, that will stop the TCAS communications telling your aeroplane to climb. Verify the isolation valve is in auto, which it is. And next it says a restart may be attempted if there's N1 rotation. So here we are, APU generator, it's come online, so we can move back up to number 7 on the QRH. APU, once available and started, APU gen switch on the affected side to on. So we only need to put the generator from the APU to feed the right hand side. So now the light's gone out because now we've actually selected the source for the right hand side. Drive light's still on obviously because there's no generation, and we can now move on. So further on into the checklist, will a restart be attempted? So for this demonstration we will attempt a restart. In the real world that's the decision of the captain. So looking back inside, we've still only got ourselves to 33,000 feet. So if we go to the part of the QRH, section 718 for me, engine in-flight start, an engine start is needed and all of the following are true. There is no engine fire, there is N1 rotation. So if there's no N1 rotation it means there's some severe damage to the engine, and you certainly wouldn't attempt a restart. So N2's rotating, N1's rotating, and there's no abnormal airframe vibration, so we're also assuming that we've no airframe vibration. So looking at the in-flight start envelope, we'll attempt a windmill start. So as you can see, you really need to be down below 24,000 feet, so I'll just expedite the video and get ourselves down below 24,000 feet, or flight level 240, just so that we can get on with starting the engine. So in order to do that, get the clearance from ATC, we can manually close the number 1 engine thrust lever. The nose, you should start to see the nose will pitch down to achieve the speed, and your rate of descent will increase. So I'll rejoin you as we get through 24,000 feet. So here we are back, approaching flight level 240, so just in the window where we are expected to start ready for the windmilling. So you can see from the in-flight start envelope that below 24,000 feet, and to windmill the airplane we really need to be above 300 knots. I did amend on the descent from the cruise page with the engine out. It changed to 235, well 235 now, it's on 237, so you could have amended that on the way down, 235 for its target airspeed. More importantly now, we're below 24,000 feet, or flight level 240, and we want to get the energy into the blades to accelerate the aeroplane and start to windmill to start the engine. So I'm going to set the speed right up to 300 knots. Notice the airplane nose is over, airplane's accelerating. So just running ahead in the QRH. So engine thrust lever of the affected engine confirmed closed. Both are still closed at the moment because we're descending. We can reduce that rate of descent now we're where we want to be. Just put some thrust on just to buy myself some time to demonstrate. So affected start lever of the affected engine confirmed cutoff, that's confirmed. And it notes that the engines can accelerate to idle very slowly, especially at high altitudes. So we're choosing a windmill start, apologies, engine start switch of the affected engine to flight. So that's to increase the chances with the ignition for the engine. And then the next step, once N2 is at or above 11%, is N2, it's at 51, so that's way above. Engine start lever of the affected engine to idle. So engine start lever to idle. And then here we're just monitoring the engine. Keep your hand in reality on start lever just in case it goes to exceed any of the EGT exceedances. Here we are, it's starting to get lighter. And we're only 1,000 feet above the target altitude now, so just so we get some clearance to flight level 130. So next part of the QRH, EGT increases within 30 seconds and a normal engine start occurs, which it looks as though it has. Be very careful with the thrust levers not to increase the thrust too quickly. As you can see, it's responding to thrust lever movements. Next, engine generator switch on the affected side on. So, gen off bus has gone out, so it's feeding the right hand side from its own generator, and the APU gen off bus light has illuminated, showing that the APU isn't feeding any of the buses. Pack switch the affected side back to auto. Engine start switch as needed, so we can put this back to off, and the APU is needed, so no real reason if we didn't want the APU burn, maybe decide to keep it on. In this case we'll switch it off so we don't burn the fuel. And then transponder mode selector back to TARA now, so we can accept climb commands. And here we go, 140, so we could elect level off at flight level 140. Well, now we have both engines operating, we can rearm the auto throttle. So there you go, control of the auto throttle once again. So MCP speed, so I've set the speed in the window. What I could elect to do, let's climb back to let's go to flight level 190, engage level change. So the thrust goes to N1, the climb thrust. MCP speed will pitch the aeroplane to achieve the speed in pitch. And then in the cruise page, we can tell it that actually this time we want to cruise at flight level 190. Execute that. And that's going to give us our new target speeds. So once we reach flight level 190, we could put VNAV, re-engage VNAV, and then that'll fly the speeds that are in the FMC. Apologies for the initial side having to do the thrust levers and the fuel control to cut off earlier than it should have normally been done in the demonstration. It's a glitch on the system that's just restarting the engines when I don't want it to, but it helps me to demonstrate a little bit clearer. Hope it's been good. If there's something that's not clear, please add in the comments below. Hope you enjoyed the video, and I look forward to the next one.